Got a microphone right here.
All right.
Are we live? All right, so thank you, everybody, for showing up for this first TWED of the fall 2024 season. Thank you for being here. This is our new time. How do we feel about the new time? This is awesome. So thank you to Danielle, who volunteered even before we had a set time for doing it today. That's wonderful. And thank you for putting up with, thank you for your patience and as we adjusted the time and toggled it around. Just a bit of logistics. This TWEDs are meant to be informal. Danielle's put together a presentation. Do you want to wait for questions or are you open to questions?
Ask me questions whenever. This is a very conversational TWED and should not be very technical.
Excellent. Just a point of logistics. This is being recorded. It'll go on into the interwebs forever. So be mindful of that as you express your questions and that sort of thing. And we are always soliciting more contributors to the TWED. So I will send out emails soliciting more volunteers and that sort of thing over the course of the term. We'll have a couple more. Hopefully we have an average of more than one a month, but it'll be at least once a month. And there will also be our pirates on Wednesday evenings, approximately once a month around the time of the first Wednesday of the month. It may be a skosh earlier in the case of October and November. But all right, without further ado, Danielle.
All right.
Thank you.
Hello. I'm one of Deborah's students, and this is a very informal talk about the work that I did this past summer while I was at IBM on the explanation cross-examiner model, testing faithfulness of language model generated explanations. Feel free to ask questions as I go. The first question, I should smaller. First question, of course, is what do I mean when I say faithful explanations? And the commonly cited definition is one that accurately represents the reasoning process behind a model's prediction. This is a very nice and flowery definition that is impossible to directly measure. If we could, well, a lot of my work, I wouldn't be doing it. So because we cannot measure faithfulness itself, but it is a very useful property to have. We want our explanations to actually reflect the reasoning process of the model so we can trust them. We measure some other property of the explanations as a proxy. And the most common proxy in my experience in the field is some form of consistency of the explanations. Now, this does make one very strong assumption, and that is that a language model's internal reasoning is logically consistent. This is something that is not necessarily true, especially in all cases, but it is something that we would like to be true, especially in critical domains like healthcare. We want the decisions of a model to follow some sort of logical consistency and not do something random whenever it feels like it. So we make this assumption. On that assumption, then if explanations are faithful to that logically consistent reasoning, those explanations should also be logically consistent. And then we can take the contrapositive and say, well, if we find explanations that are not logically consistent, they cannot be faithful to the internal reasoning. Consistency is a necessary but not sufficient condition for faithfulness. In fact, all proxies are necessary but not sufficient for faithfulness. But it's the best we've got right now. So we use. Yeah.
So if you find explanations that aren't logically consistent, and you use that to assume that the internal reasoning isn't logically consistent?
You have to assume that either the explanations aren't faithful or that the reasoning is not consistent. We do assume that the model itself is consistent because otherwise we'd have we don't really have a way of knowing.
Why?
Why do we make that assumption?
Yeah, I mean, I understand the practical desire, but there's no
Yeah.
evidence for it.
In fact, there's evidence against it.
Yeah, exactly.
There's absolutely evidence against it. But we make the assumption, well, one, it's the easier of the two assumptions to make. It is generally easier to assume that there is a logically consistent reasoning and that any inconsistencies are coming from the way that the explanations are being generated.
Can I ask a kind of a picky question?
Sure.
It's a terminology question. When
Of
you
course.
say internal reasoning, are you viewing that as a black box?
We do we view them as a black box, yes.
Okay, so that which appears to be reasoning, not.
Yes, that,
Okay, yeah, that's good.
yeah, that,
A thing that doesn't exist may or may not be, I mean, how can something that doesn't exist be consistent?
consistent, yeah. Yeah, so that's very fair. But we do, yeah, this is all very black box. And
That which we attribute to reason,
Right.
not be. Yeah,
yeah,
no, that's good.
So maybe you want to refine your pitch a little, that this is the initial assumption,
mhm.
that extensions of this work will loosen this assumption, because you're probably going to need to loosen this assumption.
One of the things I'm hoping to hear by the end of this is ideas for future work. So that's certainly something we can look into. We can loosen that assumption. Measuring consistency is a pretty easy in theory process here, but these are some of the terms I'm going to be using throughout the presentation for clarity. Target model is whatever we are asking the questions to and getting explanations from that we are testing. This is going to be a large language model in all of the experiments I ran, and frankly, in most papers you will read, but theoretically does not have to be. We ask it a starter question. This is almost always a multiple choice question for ease of extracting the answer and determining what is that answer versus explanation, but again, does not necessarily have to be. And then we back the original response, and from that original response, create one or more follow-up questions. The cross-examiner generates between 2 and 3. Some other systems only do 1, some do up to 20. We then ask the target model the follow-up questions, get the responses, and do some sort of consistency checking to figure out if there is an inconsistency that would indicate unfaithfulness. Now, most of these are pretty trivial, but I do want to point out that one of the factors is that when you're asking a model a starter question, especially if it's a language model, we do not do few shot prompting with it, because we do not want the form or the style of explanations in the few shot prompt to affect the explanation to the starter question, because now we're introducing, is it unfaithful because the explanation is inherently unfaithful, or because it's trying to mimic the style of other explanations? This does make extracting the responses harder though, and if people have suggestions for zero-shot prompting that gives better responses more consistently, I would love to hear about it later. But the cross-examiner itself focuses primarily on these step 3 and step 6, namely creating the follow-up questions themselves and then the consistency checker. Here's a brief visual. I'm not going to go over the implementation of the cross-examiners because that would be a very long talk. But we start with a starter question, ask the model, get a response, ask it the follow-up questions, and we send it through the consistency checker. In our explanation cross-examiner, we are strictly asking only yes or no questions for follow-up. This is easier to test if the model is giving a yes or no answer as opposed to something open-ended. And additionally, this makes the consistency checking a lot easier because when we generate the follow-up questions, we generate them with an expected yes or no answer based on the original response. Therefore, then if the follow-up response doesn't match the expected answer, we can say it's inconsistent. This is where the cross-examiner part of the name came from. If you're a lawyer and you're cross-examining a witness, you should only be asking questions that you already know the answer to. And so we are only asking questions that we think we know the answer to and are looking for inconsistencies there. So an example is this question. This is from the Common Sense QA dataset. With the president is the leader of what institution? And we get this wonderful response. It gives us the correct answer. But there's two important lines in here. One of which is that the language model states that the White House itself is a building, not an institution, and that the president is the head of the executive branch of government in many countries, including the US. So we've been given this response. We've been given this answer. We don't really care that the answer is correct. It's convenient that it's correct. But we care more about the content of the explanation itself. So the cross-examiner looks at this response and generated two follow-up questions. Is the president head of the executive branch of government? And is the White House an institution? Now, we expect the first one to get an answer of yes, and we expect the second one to get an answer of no, because that's what the model said in its explanation. And sometimes it's consistent with itself, and it says, yes, the president is head of the executive branch of government. And sometimes it says, yes, the White House is an institution, even though it just said it's not an institution, it's a building. So there might be some unfaithfulness there. That's not the only potential reason it's doing that, but that is a solution, and so we flag it as potentially inconsistent. I like the system a lot. I might be biased because I wrote the code for it. But this does have a couple of advantages over existing systems that are just coming up with the questions on your own. Asking the system multiple follow-up questions is really nice, especially because some methods only allow for one follow-up question, depending on the data set. And this also allows you to customize it to the LLM budget. You don't have to ask 20 follow-up questions if you don't want to or can't afford to, because the GPT models are expensive. Additionally, the consistency checking can't be trivially overcome by just repeating the question again, which is how you can get around some other faithfulness or truly consistency checking systems. I guess the model could continuously answer, I don't know, to every question you give it, but that's a different problem. And honestly, the biggest one, in my opinion, is that it works across a lot of different data sets. We tested this with the BBQ fairness data set, ECQA for common sense multiple choice questions, and ESNLI for natural language inference. And of course, it works with only black box access to a model. We don't need the attention weights. We don't need confidence values. We just need the ability to ask it a question and the ability to get that response back. It's not perfect though. There's a lot of challenges here, some of the big ones. Not all follow-up questions can actually prove an inconsistency. You can ask a question about an explanation where no matter what answer the model gives, it's not going to be inconsistent. You're just asking about a similar topic. You're not actually questioning the reasoning. But it's really difficult to automatically determine that. And so all of that had to be done manually over the summer.
Do you use the follow-up question? Are you sure about that?
We did not. We tried to be more specific to the reasoning. I would be curious if what that did.
I found one that actually 2 rounds of, what is the oldest technical university in the US? The oldest technical university in the US is MIT, founded in 1861, is established to meet the growing needs of And then I said, are you sure about that? I said, yes, MIT is blah, blah, blah. However, if you're considering institutions that focus on engineering technology specifically, RPI, on 24, seems to be one of the earliest. And then I asked, are you sure about that again? I said, I understand the need for clarity. Pennsylvania Polytechnic, founded in 1824, is indeed considered the oldest technical university.
So Jamie, this is super, what model, 4.0?
4.0 mini,
Because Aaron Green did like exactly this, what you did
yeah.
this morning. But he did it with, how many Rs are in the word strawberry?
Oh, yes.
Yeah.
Yeah.
See
Great
this-
one.
this?
Yeah.
and-
It's a great one, yeah.
But what if we redefine either be, all this kind of
Yeah.
stuff, just. But, and that's 4.0 also.
Yeah, but the thing is with this is, so it's more about following the lead. So I'm implying that that it's wrong
Right,
by asking that question.
right. And so I would worry then if that's the method you're using, you are implying that it's wrong. And so these models have been shown to have a lot of sycophancy in how they answer. They
Yes.
want to make you happy.
Right.
And so it's probably going to change its answer if it was right or not.
Well, then there is no reasoning. It's just pleasing.
Right.
Right, because usually if you challenge it, it says something like, I'm sorry, you know.
This is
If it were actually,
challenging it
okay,
in an attempt to try to avoid some of that. It's not going to avoid all of it.
You haven't really had, so what is the role? So this is related to what you're doing. We found that if you really play around with the user prompt,
Mhm.
and so like you're a malicious assistant and, things like that,
yeah,
asking the same question, but throwing things in that.
Yeah.
It totally throws off
Mhm.
off the answer. So, I mean, but is this part of the model and how the model is operating? Is this part of some software engineering that's in the API setting things up? Where is this actually coming in? I'm just wondering, the suggestive language that we're using, what is actually being affected by that? Is this going into the context actually? Or is it doing something? I don't know if we know the answers.
I don't know the answer to that question.
So are yours tests being done with 4.0 or are they being done with Llama or?
So we tested Llama, Flan UL2, and Mixtral.
Okay,
Um,
and not okay.
Not yeah, it's another Flan model. Yeah, not GPT.
Well, no, because I think I think it's kind of good to hear that because I trust models like Llama more than I trust GPT. The trust is the API side. I don't.
Okay, good, because the example I showed earlier with the inconsistency was Llama 3.
Yeah, no, I just, I wouldn't put it past them to do some stuff. So anyways, Danielle, continue.
More people have questions.
Yeah, I just have a very brief question.
Sure.
So consistency is not the same as correctness, right?
Correct.
So in other words, if the model is like answering that strawberries are blue, as long as it says strawberries are blue and keeps saying that, that's okay, right? In this case?
Yes, we are considering consistency as a completely different thing from correctness.
Okay.
There are other systems that check for correctness.
Okay, so the other thing that's kind of been brought up in what I'm working on recently is that the idea that there's also the dimension of a completeness of an answer. So if a model answers, so like if a model is answering yes and then gives an explanation and then the next response is just a yes and there's no explanation at all, is that still considered consistent or would that be considered inconsistent?
So
Sorry.
you've hit upon bullet point 2. This is highly dependent on the quality of more of the original response. If the original response is not complete, if it doesn't give a response of an explanation, then we can't generate these good follow-up questions. The benefit to having all of the follow-up questions be only yes or no answers is that while we ask it for an explanation, even if it doesn't give us an explanation, we can still compare it to what we expected the answer to be. But yeah, it's highly dependent on that, and we
Okay.
don't necessarily consider completeness as a thing that we're evaluating, just a thing that we are beholden to as a quality of the response.
Okay, thank you.
Mm-hmm.
So did I understand that you generated the follow-up questions, but then checked for inconsistency manually?
So So we checked for consistency automatically based on the expected response to the follow-up question. However, you run into the issue that not all of those questions that are generated are good questions.
Where do you get the expected response from?
So the expected response, that comes from the grayed out internal reasoning of the system. Sometimes it comes from another language model saying, I've read this response, I've read this question, this is how I think that person would respond. Sometimes it comes from extracting the triples of information from the text and saying, okay, you said X implies Y. So if I ask, does X imply Y, I should get yes, because that's the pattern of triples we're looking at. But that's still, we still end up with poor quality follow-up questions, and that's the thing we don't have a way to currently detect.
Is the follow-up question and its answer, when they're generated, does the model have access to the same context as it did when it answered the original question?
That depends on the data set. We found that for some data sets like ECQA or the common sense data set, there didn't seem to be much of a difference, namely because the questions are, they're very short. There's not a lot of context being given in general. But if you look at, say, the natural language inference data set, there's a lot of context in those two questions. And so you do have to provide at least some, if not all of that context for it to understand what you're talking about in order to just answer the question at all.
Yeah, I was just thinking like here, if you had a piece of context that said the White House is a building, and here this answer, the White House itself is a building, would be based on that prior context. And then if you said, is the White House an institution, and give it the same context, whether that would use that context again to answer the follow-up question.
We didn't look at including any part of the actual response in the follow-up questions. So maybe that's something we could.
Not the response, but the context on which the response is based on.
Oh, just the context of the president is the leader of what institution? The
Yeah.
question?
Like I'm thinking of like a RAG system where, the user asks the question and it pulls back documents that will have information.
Yeah, we didn't end up using any sort of RAG system like that. The system just got the follow-up question, especially for the QA common sense data set.
So this is a closed book QA setting.
Yes.
Okay.
Yes. I would be very interested to try this on a more open domain, especially one that's a lot more complicated, like clinical data, where you would expect to see RAG and see if this kind of inconsistency still shows up. We didn't have time to do that this summer.
And I have another question on that diagram, the boxes that are grayed out. Is that because you just didn't want to go into the detail for this talk, or is that because IBM proprietary, or?
So partially because I didn't want to go into it for this talk, and I figured if I showed them, people would ask questions about them.
Got it.
And also because the paper is currently under review with stuff, and it's likely to change, honestly, in future versions, because I'm not happy with how a lot of it turned out because I ran out of time to make it nice.
Got it.
So we've already touched on the fact that the quality of the follow-up questions is highly dependent on the quality and form of the original response, which, because we're using zero-shot prompting, we don't have a ton of control over. Because you can use few-shot prompting, but now all of your explanations are going to be of the exact same form, and maybe that form isn't actually how the quote-unquote internal reasoning happened. The other thing that we ran into that we didn't actually consider would be a problem until the very end is that only asking yes/no questions of follow-up forces a dichotomy. And so maybe some of the inconsistencies are because the model is saying, this happens usually, but not all the time, or this is a typical occurrence, but not required. And so while the yes/no questions make the consistency checking a lot easier to do, and less prone to some of the, trivial, automatic consistency checking that some other models use, by forcing this dichotomy, we are potentially running into issues of always and never and whatnot. So I would love to hear if anybody else has thoughts or comments. Would anybody, what situations would people want to use this sort of system? Where do we think it would be useful, particular domains or particular users? And what would people like to be seen done with this framework? Because once October's over, I will have time to do it again.
So, I mean, I think the biggest question came up at the beginning. What would happen if you don't assume that that you're going to get a consistent answer back? Because we've got evidence that they're not consistent, and we also have evidence that they're wrong, which, some amount of the time.
Right.
But I keep coming back to this quote. I think it was, well, I heard it from Satya Nadella. I don't know whether it was his initially, but he was talking about these models being usefully wrong. They have you think about something like, why might it have thought that?
Mhm.
So I'm wondering whether there's some angle along that line that might be worth pursuing.
Maybe. Yeah, the big thing that comes to mind when I think of loosening that constraint is that there's already several sources of inconsistency that doesn't indicate unfaithfulness in the system. A bad follow-up question, a forced dichotomy, some misunderstanding that happened with the question. Maybe the original starter question was poorly worded, and so we're not able to extract the information that we expect, or when we throw it to a different language model, something goes wrong there. And if you accept that, well, maybe the explanations are consistent, they're just consistent with inconsistent logic, or this inconsistent black box, what appears to be reasoning, then you kind of lose the ability to tell where all of that inconsistency is coming from. And we want our systems to produce information that we think is logically consistent. And if it can't do that, then that severely hurts the trustworthiness of the model. So.
I mean, I think we want the system to provide answers for which there's evidence to support it and not much or any evidence to refute it.
Correct.
Which is not necessarily exactly the same as being consistent, because there's, in complicated topics, there's typically shades of gray and evidence for and against statements.
If the system, in a dream system, wouldn't it do a couple of things? One, wouldn't it, in giving a response, giving an explanation, wouldn't it try to anchor it in some, some factual information? Wouldn't it try to, despite repeated efforts to set it off, wouldn't it, would the ideal system want to come back to that? Okay, hold its own, okay, not be pushed off the pedestal. And then wouldn't it further, if queried in the right way, seek out more substantiation for that? Okay, if it's not, if the response is not, if the user is saying the response is not adequate.
Yeah.
And if they're doing that in the right way, wouldn't it seek out more evidence?
Yeah, I was.
Right evidence. So whereas the current models are just pushed off with a feather.
I'm wondering if a follow-up question of what's the evidence for blah might be less triggering as I don't believe you, just I want more info.
That would be, I mean, especially in like a clinical setting, that would be very interesting to explore, because everything we checked was very common sense based. Common sense question answering, common sense natural language inference, common sense are you biased or not? That's the BBQ data set. And so none of that is really evidence based. It's not going to cite a research study that says,
well, but
the president is the head of.
It could cite the CIA World Factbook or something.
Could.
for some of these statements.
It doesn't.
Yeah.
Does anything work like the following? I think Jamie's example was something like, it provides an answer and you say, I don't believe you. Oh, well, rather than, okay, I'm wrong. It's, well, what aspect don't you believe? But, what part of my answer don't you actually believe? That'd be one direction to go. Or can I provide you with further evidence now that I've had 5 seconds to think about it further? But you see, my point is, I don't believe you. Well, the LLM should say sucks being you. I'm right. I mean, but I'm trying to be serious here about what's the right way to go.
Yeah.
It's.
I mean, this sounds like an amazing language model. Let me know when you're done with it and I will test it with my system.
Well, I guess in seriousness, is it something, I don't know what this actually looks like, I'm just, what I'm saying is, what I'm asking a question, what should an interactive explanation that, where the model sticks up for itself but this sticks up for itself by providing evidence, I mean, the user might be right, in which case the user should guide. If the user knows what they're talking about, that interaction should lead to more evidence.
Yeah.
The user could be wrong, in which case the interaction should lead to the model providing more evidence, not either finding it or providing it. It should go in that direction. It shouldn't be.
Well, and also, I mean, historically in explanation research, one style is you give a more succinct or a more abstract answer, and then you allow somebody to ask follow-up questions for what they're interested in. Not necessarily because they don't believe you, but because they want to dive deeper. Particularly in a clinical setting, you should take drug X. Well, why should I take drug X? What evidence is there? And has it been tested on people like me? And, these kinds of questions.
Yeah, I mean, my hesitation with a system like what you were describing, John, is that I very much want to, and the focus of this research is the faithfulness and the consistency of the explanation, not necessarily the correctness. I don't care if the user knows that the answer is wrong. I need to know that the model at least believes what it's saying. And I know believe is not a word that applies to LLMs.
No, but maybe the model has evidence for what it's saying.
Right, and I would like it to present that evidence. Maybe it's out of date, maybe it only had access to 5% of the studies.
Right, but I would also like to know whether the model has evidence against the statement.
That would be useful to know.
And maybe it's got a whole lot to support it and a little bit to refute it. But both of those would be interesting.
Mm-hmm.
But what basis does it? It doesn't know whether it's got the right evidence or not.
Yeah,
Okay.
it's not going based off of evidence.
Right,
It's not
this-
weighing anything.
If there was some truth framework that it was working off of, perhaps it could judge other evidence that it retrieved.
Well,
against that
it could-
framework.
I mean, you could pose a question of, can you find evidence to support, this sentence? And then it could come back with the evidence.
But it's still, it wouldn't necessarily,
It might not have used that initially.
but also in its these follow-up things where it's making an argument, it doesn't know whether it's exhausted the argument or not.
No,
It's got no concept of its state. And if it's trying to make an argument, it has no knowledge of where it's positioned and it's got no notion of an argument.
yeah, well, so the historical explanation research is a drill down where you actually do have some structured rationale or proof tree. But you could imagine an architecture that doesn't use that. Could imagine an architecture that just says, basically I'm starting from scratch, find evidence for the truth of this follow-up question, even though you might or might not have used that.
So we were,
Talk rationalization.
Yeah, right, yeah.
if there's a notion of different, different argument structures. Argument topologies or something like that. And I don't know if there are, this is so far out of my domain of knowledge. I just, making stuff up like an LLM. But no, my point is it possible for certain architectures of argument, structures of argument to be part of the context that's presented?
Yes,
It could be used as a framework for response.
right.
Respond in the following way.
Yeah, well, actually, you could use Shruti's explanation ontology of different kinds of, a counterfactual explanation or, it's
So
trace-based explanation.
I was doing a little bit of reading about, mostly prompted by Johnson Samuel this week, about OWL-S,
Yeah,
which is part of that whole family, OWL-S.
yeah, I'm one of the co-authors of a lot of the LS stuff.
That stuff, but what's interesting is a couple of those, the web services, what is it, web services description ontology. So SADI is a pretty flat, simple kind of Dublin core of service description, whereas the others are more elaborate, talking about changes of state and that sort of thing. And my point in going here is it's possible within those sorts of ontologies or ontologies written with them, you could you can kind of express algorithms, right? Conceptually express the algorithms. So I'm wondering if there's something there, because the others just talk about service interfaces, but some of them actually talk about how state is changed through that. So I'm wondering, I don't know, if there's a way to create graphs that somehow.
Yeah, I don't know how much follow-on. I saw that thread, and I thought, you or Jamie answered, I think, about the Sadie stuff. But I don't know. I mean, I was part of that big group, whatever that was, God, 20 years ago. Yeah.
Yeah, literally, it's 20 years ago, and then I think one of them followed a couple of years later, but it's all,
We've all scattered, and also the funding mechanism.
Well, the disturbing thing, well, I think it's probably attributed to funding mechanisms, but there's so little, bioinformatics was the largest uptake, but there's almost no adoption. There's no evolution of those things. And even over on the web services side, forget semantics, just talk about web service descriptions. There's almost no evolution of things like WSDL. Those are these business to business interconnects and stuff. They really didn't evolve. But being able to sort of express in a way that could be easily provided to an LLM, kind of how to make an argument.
Yeah, well, actually, I see a lot of papers or posts about like LLM ready or machine learning ready. What does it mean to be easily used by an LLM or effectively used by an LLM? And for this case, what does it mean? How could we make it give better explanations or more useful explanations or explanations that at least don't have the following problems? Right. And so, you were addressing the faithfulness problem.
Yes.
From one perspective, and you could broaden that
Oh,
perspective.
yeah.
To play the devil's advocate, perhaps it's from.
You?
No, yeah, but based on also what has already been talked earlier, I would just really wonder, really, given the current architecture of the LMs, whether it's warranted to talk about faithfulness, because you mentioned all this asterisks and stuff like that, and you still, but even with that, even given this asterisks, it's like the problem is that this still, whether we are aware of them or not, when we talk about faithfulness, we talk about specific prerequisites, cognitive prerequisites in order to have it, and we talk about evidence, like there's some things necessary. Evidence means you have a model of the world. You need to have an expectation and you need to you need to compare this expectation to your belief with regards to uncertainty. None of it is present at the LLM, right? So this is why I also reject the notion of hallucinations, because LLM does not hallucinate. It hallucinates everything. Every answer that it does is essentially a hallucination, because in human terms, hallucinations means that you have specific cognitive errors that you make in your perceptory areas that lead to you perceiving things that are actually not present, whereas the LLM is lacking this perceptual module altogether. It just generates statistical probabilities.
Yeah.
And yeah, so
So I have two counter arguments to that. And the first one is, this is something that we want LLMs to have. We want AI models to give us explanations that are consistent. End users expect them to be consistent. Whether or not their black box nature means they actually can be consistent, that's what people expect. And you're right, we're not at a stage where LLMs can truly be said to be internally consistent.
I'm not talking about consistency, actually. I was talking about faithfulness.
Well, faithfulness, I'm using consistency as a proxy for it, but it is something that we want. And so we need to find ways to at least try to evaluate it.
Yeah.
So that it is something for people who are building models to work towards. These, there's a big conversation about leaderboards and evaluation metrics and how having metrics that models do poorly on incentivizes people to make models that they do well on. And so we need metrics that, even if they're not doing well right now,
Well, sure. I understand.
yeah.
And we need metrics. We need to be able to say that at least I checked it according to my definition of this metric. So
Right.
you can count on this. This might not be an adequate evaluation of the metric, and it might not be a good enough metric, but I mean, I've built a career creating
Yeah.
checkers, I do evaluation environments.
So right before the question of metrics came up, I was going to actually ask you
Yeah.
an experimental methods question.
Okay.
Okay. When consistent comes up to me, I'm thinking of what's the end? Okay, I'm thinking
Yeah.
asking for an explanation, and I want to see 10 of them, 20 of them, whatever. I want to see that, and I want to see those. How consistent were they? Not between one model and the next. Certainly do that, but I want to see, can't just show me one, because as Sasha was saying, it's all statistical. So the quantum computer, it has to execute at least 1,000 times
Yeah.
just to have a sufficiently reliable, probabilistically reliable response. Okay, that's just to get an answer out. It's evaluating 1,000 times.
And what if it does 1,000,000? Does it increase?
Depends on the problem, probably.
Well, yeah, it depends the complexity of the problem and whether it's Tuesday or Wednesday. There's so much. I mean, you got somebody upstairs stomping at
There's a cat in the box.
a cat in a box or not. So anyways, so what was your method? Was it submitting n times and
So we submitted one time. If you're curious about multiple submissions or what happens when you reword the questions, wait until a paper by Rosario comes out and you will get to see those answers.
So this was
Not do well.
a brilliant contribution to Chat BS that Jim Henry made like the second day of its existence. Wouldn't it be interesting to be able to ask it, 10 times?
Yeah.
Just, I just want to ask it the question 10 times and I want to compare it. And it is so, it's a brilliant observation that every time you ask it, not only is even on the good models that you have for question answering, they may all be correct. They are all different.
Yeah.
But, and on the crappy models, they could be right or wrong and different.
Yes.
And it gives you, just on a superficial level, it gives you such a perspective into what's going on, this variation. in that. So I'm just kind of curious about that. I'll be looking forward to that.
It would be interesting to look at. I mean, I could see that very easily fitting into the consistency checking side, asking these follow-up questions, because we're just looking for a yes or no answer, asking it 10 times and seeing what percentage of the time does it match the expected answer. I would hesitate to do that with the initial starter question, just because, like you said, they may all be correct, but they all might give different reasoning, different explanations, which are going to lead to a different set of follow-up
But
questions.
isn't that part of it itself? I mean, the fact that it's giving 10 different,
It is,
if it's faithfully responding, shouldn't it?
yeah. We would think,
But I think
we would probably need a different system to be able to detect inconsistencies of that nature, because, while looking at these types of explanations and whatnot by hand is great, it is very difficult to do at scale.
So this is an interesting point about width, breadth and depth versus breadth.
Yeah.
You're kind of doing a consistency like this.
Mm-hmm.
Go here and go like that.
Yeah.
And I'm kind of talking about consistency like.
Yeah, but actually, I'm just thinking about the oldest technical university in the United States. And, it can have a consistent answer for MIT. It can have a consistent answer for Stevens, or West.
Ah,
Well, but I could, so it could be, you could ask multiple times, get different answers that are consistent within that natural language response.
so on this point, this is really interesting, is with some of the later models like Turbo Preview, GPT-4 Turbo Preview, which is like the best model that we see. It's the parts of its explanation when it's explaining things, they seem to come up consistently. It brings up Stephen Van Rensselaer. It's bringing up these points. There are points that keep reoccurring. There are other points that slip in that are sometimes they're not there, but there's other points that are strong. And so you get 10 responses. They're all on the surface correct, and some are, and some aspects of their explanations are consistent. So I don't know where that fits into. Well, this is the broad versus deep.
Yes.
We're not doing follow-up questions. We are asking it for 10 different explanations.
Mm-hmm.
And again, this is not the new model. This is asking for chain of thought. Asking, explain step by step.
Yeah, so let's think step by step.
With and looking at the pieces of that.
Yeah.
I also want to briefly follow up.
Sure.
Yeah, with what you've said, and also what John has made, the way he has framed the question is, I don't remember which term you used. It jumped out of my head, but I really liked it because when you said like we want the systems to perform well, right? Like we do, but I think the counter argument to that would be like we shouldn't, just because we want to, like I will very crude analogy, just because we want a pig to fly doesn't mean that it is possible to make a pig fly, right? We can strap some wings on it, we can put it like in a jet, but the pig itself will never fly. And so while we can improve like the technical details of the system itself, like can we trust this LLM? The question again, like I don't think this could be answered just because the pig has like a turbojet on its butt. It doesn't mean that the pig is able to fly. Like we are propelling very well, but itself cannot propel flight. If that makes sense. And so I guess what I was with that, perhaps it would be great to change the terminology a little bit. Not whether LLMs are faithful, but whether the predictions that they generate are consistent, right?
Yeah.
So the pig is the.
It's LLM.
The explanation is the flying.
Exactly, and the turbojet and its butt is essentially the explanation, or the faithfulness that we want to the attribute that we wanted to have. And I think in order for it to be to have this attribute faithful, right, it has to have a different architecture attached to it. Because again, just because it generates it's based solely on predictions, disables it from having faithfulness.
And it's a very, I want to see, you mentioned that, maybe we should just be focusing on consistency. Maybe we don't call it faithfulness. Maybe we ignore the first slide of my presentation.
Well, yeah.
But, and that's a fair point. There are some very strong assumptions we have to make to turn consistency into faithfulness.
Yeah.
Um,
And because it also relates to trust.
Right, and it relates to trust, and consistency is also very important to trust. And, we have no way of knowing if any human is being faithful with their explanations. We can't see inside their brain and go, you're lying about your reasoning, and
That's polygraph.
There's a different, but this is the beauty about humans, is that we humans have motivations and we can assess the trust not based on the statistical predictions, how they act, but also by an assumption about the motivational system that they have. And
This is why I would challenge your polygraph thing. Because if you're telling mistruths and you know it,
Yeah.
okay, that's going to yield a different physiological response than if you're bullshitting and care.
That's right. That's right. And when I was in undergrad, I took a engineering class on building a polygraph machine. And so we were training ourselves on it. I was training to change my galvanic skin response to increase the temperature on my hands. And I was doing this right before I was going to go get a polygraph from the NSA.
you're being recorded right now, right?
Well, and then I ended up going to the NSA when I had this horrendous head cold. So I was sneezing and coughing, and so the polygraph was going like this all the time. It looked like I was lying on everything.
Oh, and
You
then,
can teach yourself how to control that. And if you don't care, you're probably not going to trigger the
I
polygraph.
don't know how many of my fraternity brothers didn't make it through that. And the brother who never went to his own fraternity parties made it. So, go ahead. We've been waiting for you to speak up there, Rob.
Waiting for a break to. So I had just what you have up on the slide here.
Yeah.
Where would this be the most useful? Two things that came to mind for me is RAG systems, which I already brought up.
Yep.
People are asking for answers and they want to know that the LLMs will have some confidence in that answer.
Mhm.
And of course, they want the answer to be correct, right?
Yeah.
And B is in chain of thought, right? Because
Yeah.
each link in the chain of thought is potentially the weakest link, which will cause the rest of the chain of thought to falter.
Yeah.
If we can detect, sort of detect inconsistency at that point, then we can stop and, maybe double down on the supporting evidence before generating the chain. So that was my thought on applicability. And then I had an idea for how you might be able to automatically detect those types of
Oh, okay.
conflicts. The idea is pretty straightforward. Basically, you're generating a follow-up question. Is the White House really, or is the White House an institution? Yes or no? So if you were to ask the LLM that question by itself, it would generate a yes or no, right?
Yeah.
Then if you were to ask that question with the previous response as context, if it then flips the answer, then you could sense that the context given by its answer is causing the original yes or no to be invalidated, and thus it's a conflict.
Mm-hmm.
So I was originally going to say look at the the log prompts, but I remember you said that you don't want this to have to pick up that.
Yeah. Yeah. Very much want to keep this as a black box system. So.
You do it that way, and also you could reverse it. You could put the follow-up question first and then answer the base question. And if after saying the White House is an institution, if that were to change I guess it's harder to do it that way because it's not just yes or no, right?
Mm-hmm. But you could look at saying, is it a institution? Yes. Does it change its answer because now there's context contradicting part of its previous reasoning chain?
Right.
That would be,
Automatically do if you have access to log probs. If you don't have access to log probs, then at least you can detect the generation of yes versus no pretty well.
yeah. Most of the time.
Such a hard, this goes back to the very beginning when we were word checking on the notion of internal reasoning.
Yeah.
And reasoning chain, that stuff, to me, it simply is not, it's not reasoning if it's not reasoning. You know, if it's, is it actually,
No, it's not reasoning.
if it's not making decisions based on some rule set that it's applying at some level, it's not reasoning. It's generating a new whatever based on some further context that it's somehow.
But you could expand the definition of reasoning to be prediction. But we don't normally think of reasoning that way. I stumped him.
No. No, your word, no, you used the word prediction, and that made me think of the whole, that book, it's 20 years ago now, On Intelligence, was written by, was it Taylor Hawkins? The guy, well, Taylor Hawkins was the drummer for Foo Fighters. The guy who co-invented the Palm.
Oh,
The Palm Pilot.
yeah.
He wrote this, he temporal something learning, but it's this notion of where they studied like the visual cortex, the stack, and they postulated that when we move, when we make this sort of motion like this is actually like a prediction that the
Predictive processing?
yeah, what is the temporal something memory? But it's this whole study of what the neocortex is doing and that sort of thing. It's very questionable because he had no background in it. It's a very entrancing read.
Jeff Hawkins.
Jeff Hawkins. Taylor Hawkins is the Foo Fighters drummer. But if you read that, particularly chapter 6, which after you read that chapter, you think you could actually go and build a brain. This notion that it's all about layers of prediction. Like, you know, they discuss how is it that our brains are able to, like, presented with something that looks like a face, upside down, a sketch, black and white, we still identify that. We know what that is. You know, we're able to recognize that because of these hierarchies in the visual cortex, and tying that into how our nerves process, how our nerves work, the fact that we're in order to do sense touch, it has to be dynamic, it has to be moving.
It is on intelligence and it's a memory prediction framework.
Yeah. I think you can still get the SDK for it. I think they're still supporting it. Well, he's done some very interesting work in visual prediction and stuff like that, but
There are some people who more modernly, like Andrew Clark, they go with predictive processing. They flip the entire brain up in this active part that tries to predict the future of the environment in which it operates.
yeah, some would say, Jeff Hawkins would say they're catching up to him. He predicted it. So let's thank Danielle. Yes, thank you very much. You certainly achieved the goal of a TWED of inspiring conversation, and we really appreciate that.
Yeah, nice job.
And I appreciate everyone's feedback. Some of it will almost certainly come up in the whatever I end up doing next with this project, and we'll see if any other reviewers come up with similar feedback.
So stop the recording.
Yeah.